Hello friends, in today's lecture I am going to discuss with you the effects of oil pollution. Okay, that is a part of the water pollution in BSc semester 4. So, the crude oil contains small amounts of saturated hydrocarbons, some nitrogen, sulfur compounds, metal like iron, nickel, vanadium. Because of that content like hydrocarbons and all these metals, they causes paralysis. Sometimes liquid paraffins can cause pneumonia in lungs and it destroy the tissues of kidney. Some aromatic compounds, you have to remember all these compounds like mercaptan, okay, that is in LPG, thiophene and benzothiophene are toxic in nature and also damage the kidney. So, that is 2 marks short question. What are the effects of oil pollution on a living organism, particularly that is human beings. So, if you want to write down the answer, you must remember those compounds and their effect. Then the saturated hydrocarbons here, that is saturated hydrocarbons and some metals are there. Here saturated hydrocarbons like methane, ethane, propane, they causes suffocation and respiration ailments. The oily furs of animals to lose the insulation and resulting in death. Crude oil contains carbonyl sulfides also break up into hydrogen sulfide, poisonous gas which affects the respiratory system. So, those are the effect of some components or compounds present in the oil on a human being as well as on the animals. Next, that is the some source of radioactive substances, which are what are the major sources of radioactive substance which are added into the water and water may pollute it. Number one source is the through the mining and processing of the ores. Ores, that means that is the form of the metal, okay, from which we purify the metals. Through the production of isotopes, through nuclear power plants installed for generation of the electricity, through nuclear reactors, through leakage of the nuclear detonators, through explosion of nuclear bombs and weapons. So, those are the major sources of the radioactive substances, okay, which are added into the water and water may become polluted. What are the effect? Radioactive substance in the water may causes DNA breakage, eye contract, leukemia and blood cancers. Okay, the important topic here, that is the water analysis, some of the physical properties or some of the chemical properties which are by which we can measure the parameters or the purification or the amount of the pollution in the water. For that, if the question is that how you can determine the polluted water, how much pollution is there in the water sample, then you must determine some factors or some properties like color. Color is a physical property. Pure water has no color, but due to the presence of humic acids, fulvic acid, metallic ions, suspended matters, then the phytoplanktons, weeds and industrial effluents, it give color to the natural water. Okay. If you want to determine the color of the water, 2 methods are there. Number one is called the platinum cobalt method, second is called the Forel color scale method. Okay, now here that is no concept is here when you done the practical in the laboratory there was a chart and the process is given to you. So, here in the water analysis some methods are there, and in those methods that is a process. Okay, so, you must find out the way to how you remember this process. You have to memorize it, you have to develop some shortcut keys to memorize the process of these methods. Number 1, the platinum cobalt method, that is the practical. It is a quantitative measurement of the pollutant in the water. Some material like Nestler tubes. Nestler tubes are the wide test tubes. 50 ml Nestler tubes are there. Some color standards. Okay, so here that is the process by which you can prepare the color standards. Okay, so you have to find out the way by which you can memorize this process. You have to produce some shortcut keys or some brief notes to remember this. That is 1 gram of crystalline cobaltous chloride is there, and 1.245 gram of potassium chloroplatinate in a small quantity of distilled water. So, 2 material are mixed here, the 1 gram crystalline cobaltous chloride and 1.245 gram of potassium chloroplatinate. Then 100 ml of concentrate HCl, hydrochloric acid, and it is diluted to 1 liter. Okay, this solution has a color value of 500 color units. Then prepare the standard by diluting 0.51, the series is there 0.5 to 7 ml of the solution with distilled water to 50 ml in a standard Nestler tubes. Then these solutions have color value of 5 to 70 respectively. Okay, these are our standards. Okay, these are standard solution, or we can say that it is a reference solution by using which we can identify the color value in the sample solutions. Now, that is the method. Centrifuge the sample at high speed to remove the suspended matter. First of all, what happened? We have to remove some suspended particles from the water sample, and for that the method used, that is called the centrifugation method. If you want to know what is the centrifugation, you may Google it. Fill standard Nestler tube with sample to the same level as that of the standard. Okay, here then that water sample is put or fill in the Nestler tubes. Then compare the color of the sample. Simple method is there. Now we what to do? The comparison of the color of that particular sample with those standard, that is 0 to 70. We prepare already here, that is 5 to 70 unit color unit standard solution. So, when you compare those tubes with the standard, what happen here? Compare the color of sample with that of the various standard tubes held vertically above a white surface and find one standard with same color. Then okay, what happen here? The color of the sample solution may, that is match with the above standard solution, and on the basis of that read its color value. Okay, like if the sample shows a color more than 70 units, it should be diluted with distilled water, and the color estimated is multiplied with the dilution factor. Okay, what does it mean? We have only 5 to 17 color unit standard. If the color of the sample solution is above the 17 value, then what we have to do? Then diluted the sample solution by 10 times or 20 times or 50 times. So, that is the dilution factor, 10 times, 20 and 50. And then after dilution, repeat the practical, match the color with the standard. Okay, if the sample is matched with 50 unit, then multiply this 50 with 10, because we dilute the solution 10 times. So, the answer is 50 into 10, that is 500 color unit. It is like that. Then the Forel color scale method. Okay, here also some materials are used. You have to prepare all these materials 0.5 gram of copper sulfate to 5 ml strong ammonium hydroxide and dilute to 100 ml distilled water. Solution 2, that is 0.5 gram of K2CrO4, that is potassium chromate, 5 ml ammonium hydroxide and 100 ml distilled water. Solution 3 is the 5 gram of calcium sulfate, 5 ml of the strong ammonium hydroxide and dilute to 100 ml with distilled water. So, 3 solutions are there, S1, S2 and S3. What is the method? Same, centrifuge the sample so that they remove the suspended matters, then fill the sample in clean tubes and compare its color with 22 mixture of the Forel color scale. Here those are the Forel color scale. Okay. That means in one test tube we add 100 ml S1 solution, 0 ml S2 and 0 ml S3. In test tube 2, that is 98 ml of S1, 2 ml of S2, 0 ml of S3. Okay. You know what is S1, S2, S3, here this solution, those are S1, S2 and S3. So, first of all, what you have to do? You have to prepare all this series, those are our standard solution or reference solution. Then what happen? We compare our color, we compare the color of the sample solution, the tube, with those reference and we find out the value. Okay, next, that is called turbidity. Now, why turbidity is present in the water sample or in the fresh water? The turbidity in the water is because of the suspended matters like clay, silt, organic matters, phytoplanktons, other microscopic organisms. Okay, and it is an expression of the optical property called Tyndall effect. Now, what is a Tyndall effect? That is in TYBAC semester 6 physical chemistry. One topic is there, colloidal solution. In that colloidal solution, the topic is that Tyndall effect. But here, what is a Tyndall effect? A Tyndall effect means when a beam of light is that is incident on a particle. What happens? The scattering of light is shown, scattering of the light is observed because of that particular particle. So, that kind of property, the scattering of light because of the particle is called Tyndall effect. And that scattering, how much amount of light is scattered with the help of those suspended matters? It depends only on the size of the particle, the shape of the particle and the refractive index value of such particles. Okay, turbidity when caused by phytoplanktons, that is largely because of the phytoplanktons, it considered as index of productivity. That means the amount of phytoplankton present in the water sample indicate how much productive the water is there. Okay, the fertility of the water is depend on the amount of phytoplankton present in the water, but the opposite of that, it is the suspended particles. When suspended matters or particles are present other than phytoplanktons, it restrict the light penetration. That means it decrease the productivity of the water, because as the suspended particles, the amount of particles increase in the water, what happen? It create a layer, and because of that reason the sunlight is not penetrate into the water, and because of that reason the oxygen level is decreased in the bottom of that water resource, and hence the productivity of the water is decreased. That means the process of photosynthesis is decreased. Okay, and that is the method. It is called naphtalometer, the instrument here, that is the instrumental method is there. It is naphtalometer or it is called turbidimetry. Now, sample tubes are there made of colored and scratch free glass. Standard turbidity suspension, here standard solution is prepared, that is the method. You have to remember how the standard solution are prepared. 1 gram of hydrogen sulfate in distilled water and prepare 100 ml solution. Then dissolve 10 gram of hexamethylene tetraamine in distilled water to prepare the 100 ml solution. B, that is 5 ml each of the solution, that means A and B. Okay, both are mixed in 100 ml volumetric flask. Okay, here the 1 gram hydrogen sulfate in distilled water is called solution A, and 10 gram hexamethylene tetramine in distilled water is called solution B. What happened here? Each 5 ml of each of the solution, that means A and B, are then mixed in a 100 ml volumetric flask and allowed to stand for 24 hours at 25 degrees Celsius. Then dilute this solution with distilled water up to the marks. This is a suspension having 400 naphthometric turbidity unit. Okay, that is our standard solution. Okay, then dilute 10 ml of the above, that is the stock solution, my mistake, that is the stock solution. Now, from the stock solution, 10 ml of the stock solution is diluted to 100 ml, and that is our standard material. After that, what is the method for sample solution? Set the naphthometer for 100 using 40 NTU. Now you know what is the NTU, it is a naphthometric turbidity unit. So, by using this 40 NTU standard suspension, set 100 in the naphthometer instrument, then shake the sample thoroughly and let the air bubble remove. Take the sample in a naphthometric sample tube and find out the value on a scale. Okay, put the sample in a naphthometric tube, put it in the instrument and read the value in the scale. So, that is how you can find out the turbidity present in a water sample with the help of a naphthometer. Calculation is here, turbidity is equal to naphthometer reading into 0.4 factor into dilution factor. Next point is called total dissolved solid. It is also known as TDS, total dissolved solid. Okay, salts like carbonates, bicarbonates, chlorides, sulfate, phosphate and nitrates of calcium, magnesium, sodium, potassium, iron, manganese are dissolved in natural water. The high content of dissolved solid increase the density of the water and influences the osmoregulation of a freshwater organism. So, that is the 2 mark short question. What is the usefulness of TDS in the water? So, that is here is the answer. The high content of TDS increase the density of water and hence it influences the osmoregulation of the freshwater organism. What is the osmoregulation? It is the osmosis process. They reduce the solubility of the gases like oxygen and utility of the water for drinking, irrigation and industrial purposes. Okay. So, that is the side effect or that is called the drawback of the TDS present in the water. Because of that, as the content of dissolved solid increases, they increase the density and because of that reason they reduce the solubility of the gases like oxygen, and because of that reason the oxygen content in the water is decreased and hence this water is and utility of the water for drinking, reduce the drinking ability of the water, irrigation and industrial purposes. Which are the material used for the method? That is evaporating dish, chemical balance, desiccators, hot water bath and filter paper, that is Wattman filter paper number 4, that is the gravimetric method. Here 250 to 500 ml of water is filtered out through the Wattman filter paper number 4 in a pre-weight evaporating dish. Then evaporate the sample on a hot water bath until whole water is evaporated and note down the weight of the evaporating dish after cooling it in a desiccator and calculate the TDS value. So, it is a simple method. Okay, first of all what happens, the evaporating dish is take that and weigh the empty weight of the dish, that is evaporating dish. After that 500 ml or 250 ml solution is transferred in the evaporating dish, then it is heated till whole water is evaporated, only some residues are remain after that heating. Then cool down that dish in a desiccator. After that weight again that evaporating dish. Now that weight is called weight of dish plus the residue. So here the weight of dry solid plus dish, that is after the drying, and that is the weight of the dish. By subtracting this value, you find out the weight of dry solid, that is divided by volume of samples taken, that is between this 250 to 500 ml into 100. In that way you can find out the value of TDS into the unknown water sample. Then total solid. Now what is a total solid? The difference between TDS and a total solid. Total solid, that means the dissolved and undissolved and suspended particles, all kind of particles or the materials or the matters or the compounds present in the water. TDS means only those components which are dissolved in the that means which are present in the dissolved form, those are called TDS. Here all kind of particles. For total solid, do not filter the sample. Okay, what is the method? The same method for TDS, but here to find out the total solid, the one step is removed, that is filtration. We are not going to filter out the water sample. The first step in TDS is what? We filter the sample through Waterman filter paper number 4. But here to find out the value of total solid, that step is removed. Here what happened? We take the water sample directly into the evaporating dish, and then the rest of the process is same as the total dissolved solid. Next one, that is called conductivity. Okay, I discussed this topic conductivity in the part 2 of this video. If you have any doubt regarding to this discussion, then feel free to ask me your question in the comment box. Thank you.